The story begins not with the thunder of rockets or the hum of satellites, but with silence, an eerie silence that hangs above the earth like a mystery waiting to be broken. Imagine a time before we knew the sky was alive with invisible storms, when the heavens were thought to be pure, untouchable, an empty vault of peace. It was the late 19th century, the dawn of electricity and radio, an age of discovery trembling with curiosity, yet bounded by ignorance. Scientists were lighting cities, wiring telegraphs across continents, and pulling lightning into glass tubes, but no one yet imagined that space itself was raining energy upon them. And into this quiet ignorance stepped a handful of stubborn dreamers, forgotten men with fragile instruments and boundless doubt, who would reveal one of nature's deepest secrets, that the universe is constantly bombarding Earth with invisible messengers from the stars. The tale of cosmic rays begins, as all great tales of discovery do, with disbelief. The year is 1896, in a laboratory dimly lit by the glow of radium. Henri Becquerel, a French physicist studying phosphorescence, had accidentally left photographic plates near uranium salts and found them mysteriously fogged. His accidental discovery of radioactivity shocked science. Suddenly, atoms were no longer eternal and solid. They could decay, releasing unseen power. The world rushed to investigate. Marie and Pierre Curie isolated new elements that glowed with strange, ghostly light. The Curie's discoveries turned radioactivity into a frenzy. Laboratories across Europe buzzed with excitement and a growing sense of danger. Something unseen was at work, rays that could pierce paper, metal, even flesh. Yet amidst all this fascination, another mystery quietly surfaced. Even when scientists shielded their instruments from known radioactive sources, they still detected a faint, persistent ionization in the air. Where did it come from? Was the Earth itself leaking radiation? Or was something else, something unimagined, seeping in from the sky? Most dismissed the anomaly as instrument error, a nuisance in the delicate dance of discovery. But not everyone. Enter Theodor Wolff, a German Jesuit priest and physicist whose curiosity refused to die. Around 1909, he climbed the iron skeleton of the Eiffel Tower, carrying a delicate electroscope, a simple device that measured how quickly air lost its electric charge. Wolff reasoned that if the radiation came from the ground, it should diminish with height. But when he measured at the top, over 300 meters above the streets of Paris, the ionization had barely decreased. The heavens, it seemed, were not as quiet as they appeared. Wolff's report was met with polite skepticism, the kind reserved for those who stare too long at clouds and claim to see patterns. Yet his observation gnawed at the edge of scientific certainty. Then came Domenico Passini, an Italian physicist whose story would be buried under the fame of others. In 1910, Passini decided to take the question further, literally underwater. If radiation came from the Earth, submerging an instrument beneath a lake should not matter. But if it came from above, the water would shield it. On a calm day in the Bay of Livorno, Passini sealed his electroscope in a watertight container and sank it several meters below the surface. The readings dropped sharply. Something from the sky was indeed striking Earth. Passini, exhilarated, published his results in Italian journals, calling the phenomenon a penetrating radiation of extraterrestrial origin. But Italy, still rebuilding its scientific reputation, lacked the attention of the German-speaking world. His findings were largely ignored, lost to language barriers and the snobbery of national science. Yet across the Alps, another man was preparing to test the heavens more directly. Victor Franz Hess, an Austrian physicist with an appetite for risk, believed the answer lay not beneath the sea but above the clouds. Between 1911 and 1912, Hess embarked on a series of daring balloon ascents, carrying his fragile electroscopes thousands of meters into the air. Each flight was a leap into the unknown. There were no radios, no oxygen tanks, only wicker baskets and courage. He launched before dawn to avoid interference from sunlight, rising above Vienna's rooftops into the pale blue void. As the balloon climbed, the readings astonished him. Rather than decreasing, the ionization rate increased sharply with altitude. At over 5,000 meters, it was nearly double that on the ground. The source of radiation was not the Earth, it was the cosmos. The sky itself was raining energy. Hess descended, nearly frozen, and scribbled notes with shaking hands. On the seventh flight, he brought confirmation. Radiation intensified with height, proving it came from space. The increase of ionization with altitude, he wrote, proves the existence of radiation of very great penetrating power coming from above. But when he announced his findings, the world was not ready to listen. It was 1912. Europe was sliding toward war. The scientific community was fractured by nationalism. Passini's work lay forgotten, and Hess's results, though impressive, contradicted the comfortable assumptions of physics. Still, a few took notice. The term cosmic rays would not appear until later, but whispers of ultra-radiation began to spread. After the Great War tore the continent apart, Hess's research resurfaced like a ghost from the pre-war world. Others began repeating his experiments, confirming his results but adding their own twists. In America, the young Robert Millikan, famous for measuring the electron's charge, grew obsessed with these mysterious rays. To him, they were not particles from space but birth cries of atoms, radiation from the creation of elements, a cosmic echo of Genesis. Millikan's fame ensured that his version of the story reached newspapers and lecture halls worldwide. He even coined the phrase cosmic rays. But in his eagerness to explain, he dismissed Passini, Wolff, and even Hess as footnotes. History, as it often does, chose its heroes selectively. Meanwhile, the mystery deepened. If cosmic rays were real, what were they? Light, gamma radiation, or something stranger, tiny bullets from beyond the stars? In the 1920s, as technology improved, scientists built bigger, more sensitive detectors. Balloon flights became international competitions for prestige and truth. Yet the cosmic visitors remained elusive, invisible but constant. Clouds formed around their passage, spark chambers flickered, photographic plates blurred. It was as if the universe were whispering in Morse code, and humanity had only just learned to listen. For the forgotten pioneers, recognition came too late. Passini died in 1934, largely unknown outside Italy. Wolff faded into obscurity, his Eiffel Tower experiment remembered only by specialists. Hess eventually received the Nobel Prize in 1936, shared with Carl Anderson, who had discovered the positron, a particle born in cosmic ray collisions. Hess accepted the honor with humility, but the shadow of omission lingered. Without Passini's underwater courage, without Wolff's climb, would anyone have believed him? The cosmic story was now unfolding across continents. In Japan, Yajiro Agata measured variations at sea level. In Russia, Alexander Lebedinsky designed new instruments to catch the sky's invisible bullets. And in the United States, Arthur Compton began global surveys that showed cosmic rays varied with latitude, proving they were charged particles deflected by Earth's magnetic field. The cosmos, once thought silent, was singing in streams of energy. Yet beneath the triumphs lay the human texture of science, the jealousy, the neglect, the language barriers, the forgotten letters left unread on cluttered desks. For every Hess, there was a Passini. For every Millikan, a dozen unsung experimenters whose data never crossed borders. The discovery of cosmic rays was not the triumph of one genius, but the convergence of many lonely minds staring upward into mystery. The rays themselves, born from exploding stars and distant galaxies, carried not just energy but irony. They illuminated how fragile human recognition could be. Above the politics and the pride, the universe simply continued to reign its silent storm. And so, as the 1930s dawned, scientists turned their eyes upward with new instruments, preparing to unmask what these cosmic messengers truly were. Little did they know, their quest to understand the energy of the heavens would soon open the door to the greatest power humanity had ever unleashed. By the mid-1930s, the age of wonder had turned into the age of instruments. The war had left Europe scarred, but curiosity, like the cosmic rays themselves, could not be stopped by borders or fear. High in the Andes, at laboratories perched above the clouds, and in mountain stations across Europe, physicists began capturing the ghostly traces left by cosmic rays as they struck Earth's atmosphere. What they found would reshape not only physics, but humanity's very sense of its place in the universe. When a cosmic ray hit the upper air, it shattered atoms like glass, producing a cascade of secondary particles that rained down in what scientists called showers. Each burst was a miniature storm of creation and destruction, a celestial fingerprint left in the sky. Cameras caught these invisible collisions through thin chambers filled with vapor, cloud chambers invented by C.T.R. Wilson, and the photographs looked almost alive, faint curling trails like smoke frozen in glass. These were the handwriting of the cosmos, proof that the universe was not empty but in perpetual conversation with us. And yet, even as discoveries piled up, the credit remained uneven. In lecture halls across America, Robert Millikan stood before audiences describing his birth cries of atoms, insisting that cosmic rays were electromagnetic radiation rather than matter. In Europe, others quietly disagreed. They saw evidence that these rays carried charge, that they were, in fact, particles accelerated by magnetic storms in space. Millikan, ever proud, refused to yield easily. He floated detectors on lakes, climbed mountains, and published elaborate arguments defending his theory. His fame turned his interpretation into near-orthodoxy, while the quiet dissenters, Compton, Clay, Rossi, and others, fought to prove otherwise. It was Arthur Compton who finally broke the stalemate. By mapping cosmic ray intensity from equator to pole, he showed the variation followed Earth's magnetic field lines, clear evidence that cosmic rays were charged particles, not light. The finding was elegant, unarguable, and it humbled even Millikan, who eventually conceded defeat. But in that defeat, physics took a leap forward. Cosmic rays were now seen as travelers from distant space, fragments of atoms hurled across galaxies at almost the speed of light. To detect them, new instruments arose: Geiger counters, coincidence circuits, cloud and spark chambers, each an extension of human senses into realms unseen. In these flickers of light and noise, the structure of the atom was revealed more clearly than ever before. Scientists began finding particles no one had dreamed existed: muons, pions, kaons, ghostly cousins of electrons and protons, fleeting but real. Cosmic rays became nature's own particle accelerator, striking the atmosphere with energies far beyond any machine on Earth. The universe was, it seemed, a vast laboratory. Yet the men who first glimpsed its signs, Wolf, Pacini, Hess, remained shadows in its story, their names footnotes in textbooks while their courage breathed through every experiment that followed. Hess, by then in America, watched the rise of nuclear physics with quiet awe and sadness. His discovery, once dismissed as trivial, had become the foundation of a new science, and in a dark twist of fate, a doorway to weapons capable of annihilation. For as physicists studied cosmic rays, they uncovered the nature of nuclear forces, leading to the chain reactions that would one day light cities and destroy them. The same curiosity that had lifted Hess in his balloon would, within 3 decades, lift mushroom clouds over Hiroshima. And yet, it was not guilt that defined Hess's final years, but wonder. In his lectures, he spoke softly of the unity of creation, of the strange beauty that the universe's violence revealed. The rays from the heavens, he said, remind us that energy and life are one, that destruction and creation dance together in the stars. Meanwhile, in Italy, Domenico Pacini's name flickered briefly into light again when younger scientists rediscovered his forgotten papers. They realized he had anticipated Hess's conclusion years earlier. He had simply been unheard. Recognition came late, posthumous and faint, but his story inspired a new generation to look deeper, to question the comfortable narratives that history writes for itself. The Second World War scattered Europe's scientists once again, and cosmic ray research moved to new centers in Chicago, Berkeley, Tokyo, Moscow. Mountain observatories became temples of discovery, their instruments catching cosmic visitors from the deep night. Young physicists huddled in cold huts, their equipment buzzing like nervous hearts, waiting for a single burst on the counter that would prove a theory right or wrong. They chased showers across stormy ridges and watched cloud chambers bloom with silver trails, each line a whisper from a distant star. When the first particle accelerators arrived in the late 1940s, they found what cosmic rays had hinted at all along. The subatomic world was far more crowded than anyone imagined. Every collision opened new mysteries: antiparticles, mesons, strange quarks, until physicists realized they were standing on the edge of a vast ocean of unknown forces. And through it all, cosmic rays continued to fall, unbothered by fame or politics, a silent rain of truth. In the decades that followed, satellites replaced balloons, and detectors climbed from mountaintops into orbit. In 1962, scientists measured cosmic rays of unimaginable energy, particles so powerful they could split nuclei apart. These ultra-high-energy rays came from the hearts of supernovas, from quasars and black holes millions of light-years away. Humanity, at last, understood that we were connected to the violence of the cosmos, that every atom in our bodies was once part of a star that exploded and sent its ashes across time. The discovery that began with fogged photographic plates and humble electroscopes had become a story of cosmic belonging. And yet, beneath the grandeur, there remained the simple human truth: discovery is never the work of one person. It is the inheritance of courage, the accumulation of small, stubborn acts of curiosity. Wolf's trembling climb up the Eiffel Tower, Passini's lonely immersion beneath the sea, Hess's freezing ascents into the dawn. They were not separate moments, but chapters in one long conversation between humanity and the universe. Their instruments may have been crude, their fame fleeting, but they listened when others dismissed the noise. They trusted the sky's whisper. And because of them, we know that the universe is alive, restless, and forever sending us messages in the form of invisible rain. Today, when cosmic rays strike our atmosphere, they trigger detectors on mountaintops and deep underground, part of a global network connecting thousands of scientists across continents. Each flash of light, each signal, is a continuation of that century-old dialogue between wonder and proof. The forgotten scientists have, in a way, become immortal through the data that still bears their signature. As the narrator's voice fades and the stars fill the screen, remember that every second, thousands of cosmic messengers are touching you, passing through you, fragments of ancient explosions whispering across space. The next time you look at the night sky, imagine that invisible rain falling on your skin and think of the men who first dared to believe it was real. Their story is not just about physics, it is about faith and curiosity, the only force strong enough to pierce the dark. And as their names echo once more through time, Wolf, Passini, Hess, Millikan, Compton, let them remind you that truth is patient and the universe keeps no favorites. It speaks to anyone brave enough to listen. Subscribe to Dark History Files, where the past isn't just remembered, it's resurrected.